Hello, ladies and gentlemen, and welcome to another set of notes. Today we are going to be talking about arc lengths and central angles. So let's get started on it. Before we even get into any actual math, what we need to talk about today is some vocab words because we're going to be throwing a lot of different vocab words at you today. So the first few vocab words we got to kind of learn about is the central angle. So what this is the essential angle is an angle with a vertex at the center of a circle. Okay, and usually its angles, its legs of the angle are going to be the radius of the circle. An arc is an unbroken part of a circle. So, and when you talk about arc, we usually have two different types of arc. We have the minor arcs here, and then we have the major arcs. So, so in this case, we have minor arc YZ, and then we have a major arc YWZ. Okay. So the big difference, minor arc is doesn't include another reference point. Major arc includes another reference point. So minor arc is always, if you have, you're always going to have both of these kind of laid out. Minor arc is always going to be the smaller one. And then the major arc is just everything else. But you need a reference point for that, and that is that W. So if I were to just give you a picture and say, hey, find the length of arc YZ, you know I'm talking about a minor arc. If I say find the length of arc YWZ, you know I'm talking about a major arc. So the measure of a minor arc YZ is the measure of its corresponding central angle degrees. So the measure of the arc is equal to the degree measured inside there. The length of YZ is a part of the circumference of the circle, not an angle measure. So here we can tell it's talking about an angle measure because it uses this little m there. Okay, like when we talk about measure of angle ABC. You guys always wondered what that little m in front of that angle stood for, and that means, you know, the measure of the angle. They're kind of trying to replicate that here with this notation, measure of angle YZ. Then the length of YZ is just how far, like the distance here to here of the circle. It's like part of the circumference. It's part of the distance around the circle. All right, then when we're talking about a sector of a circle, it's just a region bounded by the radii of a circle. So here, the sector of a circle is just this area right here. All this shaded stuff, this is the sector. So when I'm talking about sector, I mean area, okay? All right, so we're gonna get to these in just a second. In general here, this is the creme de la creme of this lesson. This is the, if you don't get anything else out of this lesson, I hope that you guys get this stuff right here. In general, if we have a major arc or minor arc AB, and if its measure is x degrees, then the length of this arc AB is going to be equal to this stuff. Okay, and the area, so this whole orange area of the sector AOB is going to be equal to this formula. These two things here should look very familiar to you guys. Where have you seen this part of the equation before? Where have you seen this part of the formula before? That's right, in the last lesson, right? When we talked about circles, this 2 pi r is the formula for the circumference, and this pi r squared is the formula for the area of a circle. Now what we're saying is we are just taking a part of that. And how much of it? Well, it depends on what the angle measure is between your two radii. Okay, and that'll tell us how much of the circle we're actually taking into account here. So let's give it a shot up here in this example, right here. So here they're asking for the length of AB. Are they asking for the distance from A to B like this, or are they asking for the angle measure? Well, there's no little m in front of the AB, plus it says length, so I guess they're asking for the distance between A and B along the circle. Luckily, we have a new formula for that. So all we have to do is take the degree measures, which is x, and we have to divide it by 360, then multiply it by 2 pi r. So I'm going to take my angle measure here, which is 60. So I'm going to have 60 over 360 times 2 pi, and then r in this case is 5. All right, so 60 over 360, I believe that is 1/6. Just give me a circuit. 60, 360 is indeed 1/6, and then 2 times 5 is 10. Multiply that out. So 1/6 times 10 times pi, and that's going to just be equal to 10 over 6, which is 5 over 3, 5/3 pi. And that is your length of AB. That is your arc length. All right. Now we do the same thing to find the area of the sector. We need the same things. We need this degree measure and we need the radius, and we just plug it into this formula right here. So very similarly, 60 over 360 times pi r, which is 5 squared. So it's 1/6 pi times 25. Oof, man, sorry about my handwriting. 20, and then it's just going to be 25 over 6 pi. All right, and that will give, so that's going to give me the entire shaded area here. Okay, so moving on. So that's like your example. One thing I want to note actually here is sometimes I might accidentally be using this formula for the length of AB instead. So sometimes I'm going to use this in our examples. Now my question to you is, are these two things the same? Are these two equations the same for the arc length? Yeah, they are. Because if I were to multiply x by 2 here, I would have 2x over 360, and then it would simplify down to this. So I'm probably going to use this a lot more because I think it looks just a little bit better and it's easier to calculate. So if you see me using this, it's the same thing as this. Okay? And it doesn't matter to me or your teachers which one you use. It's completely personal choice. Use what you want. All right, so all right, they want us to do a bunch of calculations here. So sector AOB is described by giving the measure of angle AOB and the radius of the circle O. Find the length of AB and the area of sector AOB. This is just a bunch of plugging and chugging. So make sure you have your formulas ready because we're going to take each of these things, plug it into the formula, get out an answer, and we're just practicing here. So let's give it a shot. So length of AB, I'm going to use this formula right here. So for A, length of AB, I got to take my angle measure, 30, over 180 times pi times the radius, which is 12. Get your calculators handy because I am not good at arithmetic. So when I plug this into my calculator without the pi, this is going to be equal to 2 pi. Okay. And then area of sector AOB, same thing, but now, so it's going to be 30 over 360 pi r, which is 12, squared. So again, plug this into your calculator and you are going to get 30 over 360 times 144. You get 12 pi. So again, you're literally just taking these things, plugging them into the formula, getting out an answer. Let's try the next one, length of AB. So for part B, we are going to be using these two values. So we're going to have 45 over 180 is equal to pi r, which is 4. 45 divided by 180 gives me a decimal number that is, oh, pretty. It's 0.25. Multiply that by 4, and you get out just pi, 1 pi. So just plug all this into your calculator. You'll find that this and this just cancel out to give you 1 pi. All right. And then area sector AOB, 45 over 360. Pi r squared, 4 squared. So this is 0.25. This is 16. So 16.25. Oh, wait, no, it's not 0.25. 45 divided by 360 is 1.25 times 16, and that is 2. So this is 2 pi. See what I mean? Just a lot of plugging and chugging. All we're doing is taking these things, putting them in our formula, or plugging them into the formula given, plugging them in our calculators, and we're getting out an answer. So let's do C. So C, again, exact same process. We use a different color. Green, we're working with these numbers this time. So 108 over 180 pi r, which is 5 root 2. Ooh, this one's kind of a little bit nasty because we got a square root, but I think we can handle it. So plug it into my calculator. I get 0.6. So I get 3/5. I'm gonna need more room. Do underneath it. So I get 3/5 pi times 5 root 2. Okay. So here, if I'm going to multiply this and the 3/5, the 5 there and there are going to cancel, and I'll be left with 3 pi root 2 is my answer for the arc length. All right, and then the area sector. So the area is 108 divided by 360 pi r, which in this case is 5 root 2 squared. All right, 108 divided by 360 is going to give me 3/10. So 3 over 10. And pi. Can't forget the pi. And then we got to square this. So when I have two things here inside the parentheses being multiplied together, I have to take the square and apply it to both of them. So 5 squared is going to give me 25. And then root 2 squared. So if I did root 2 times root 2, what that's going to give me is just the squares are going to cancel out, and I'm just going to be left with the 2 there. So that's just 2. All right. So then we multiply it out. So this is 50. 50 times 3 is 150. And this is going to be equal to 15 pi. That's the area. All right, lastly, a lot of plugging and chugging here. Lastly, we got this. So we are given the arc, the angle measure is 210, the radius is 3. So I'm going to take 210, plug it into this formula. pi r, which is 3. Ooh, that's not a 3, that's a 3. Plug this in your calculator. 210 divided by 180 times 3. I get 3.5. All right, then area sector AOB, you just take the 210, so we plug it in here, 210 over 360, pi r, which in this case is 3 squared, and that is going to be equal to, so 210 divided by 360, I believe is 2/3. Nope, but that's okay. When we multiply this out, we get 5.25 pi. Bada bing, bada boom. So again, all it is taking these values and plugging them into your respective formulas. Okay. That's all I did with all this. Your calculator is your friend here. I would say plug it into your calculator, make sure you get your answers correct. Yeah, they go by pretty fast once you do them a couple of times. All right, now example 2 is different. So for example 2, we are given the area of sector AOB is that, and the measure of the arc AOB is 315. We need to find the radius of circle O. So what we're going to do here, what I'm going to do is we're going to write out the equation just so that we have it. So we are given the area of the sector. So the area of the sector is equal to x over 360 pi r squared. Here we're given the area of the sector. So this is going to go in where the area is supposed to be. We are given the angle measure, 315. So that is going to go in where the angle measure goes, right there. And we need to find the radius. So our radius here is going to be unknown. So we take our respective parts, plug them in, and then everyone's really good at algebra. So I feel like we're going to be pretty good here. Okay, 360. All right. So that's a lot over there. 315 over 360. Let's see if we can simplify that a little bit. So 315 divided by 360. Okay. Let's see here. So this would be simplified down to 363 over 72. Yikes. Is that a nice, we can divide both those by 9, I think. So 63 divided by 9, 7 over, this will be 8, 7/8. Okay, so we got it. It simplifies down to 7/8. So 7/8 pi, whoops, sorry, whoopsie. All right, so I'm moving this over. So 7 pi over 2 is equal to 7/8 pi r squared. Okay, so in order to solve this, there's a couple of things we need to do. We need to get this r squared by itself. So that means we need to get rid of this fraction piece and we need to get rid of this pi. The first one that would be the easiest to get rid of is this pi. So to get rid of the pi, all this pi is being multiplied by everything over here. So I simply got to divide both sides by pi. Now don't worry, it's not as difficult as you think because here what this is going to turn into is just 7 pi over 2 pi. And the pi's are just going to cancel out there. So we are going to be left with 7 over 2 is equal to 7 over 8 r squared. Now to cancel this out, we need to multiply by the reciprocal. Okay. Actually, I'm gonna do this in a different color so that we don't get lost here. So I'm gonna multiply it by 8/7. All right, so here these cancel out. And here 8 times 7 is going to give me, well, actually, you know what? We could just even leave it like this. 8 times 7 over 7 times 2 is equal to r squared. These 7s on top and bottom cancel, and then I just have 8/2. And 8/2 is just 4. So 4 is equal to r squared, so square root both sides to get rid of that r squared, and we end up with 2 is equal to r. So how come we didn't include the negative? How come we didn't include -2 here? Well, it doesn't really make sense for the radius of a circle to be negative since it's a length, so we keep it positive. All right, so that is the formula part of this lesson. Okay, so here we went over vocab, we went over the formula, and we did a lot of plugging and chugging. Okay, so a lot of this stuff you just plug it into the formula and then plug it into your calculator and get the right answer. Here we had to do a little bit of algebra, which is great. And you guys are great at algebra, but we are going to end up with a lot of fractions, so make sure you are solid on your fraction work. The next few examples I'm going to tackle on my next video because they take a little bit of time and this video is running a little late. So thank you all for listening. Tune into the next video to figure out how to find these problems, these 4 problems. All right. Thank you very much. Have a good day. See you in class.